Adding and subtracting vectors. So if you wanted to start at A and go to C, one way you could go there is directly by going from A to C. But you could also, if there was another pathway from A to B and another pathway from B to C, you could also get from A to C by first going to B and then to C. And we get the following vector equation, that A to C is the same as going from A to B plus B to C. Of course, if you were measuring distances, you will have traveled longer. But as far as where you started and where you ended is still the same. And this is the idea of vector addition. If you're adding two vectors together, you're just looking at where did you start and where did you end. Now, we call, if I take out our highlighter, the vector AC, or the vector W, the resultant, or the answer of what you get when you added AB and BC together. So if you have one vector AB and it's labeled as the vector U, then the vector in the opposite direction would just be multiplying by a negative. And we've seen that already, where you just make multiplying by a -1 just changes the direction of the vector. It has the same length, just going in the opposite direction.
So BA is U, and then AB would be negative.
That's right. So we can draw these out. If A is 2I minus j, so here is, I'm going to draw A, 2I minus j. That would be vector A. And B is negative I plus 3j. Oh, I want to switch colors. I'm going to clone these ones. You can underline, you can put a little arrow over top of them.
I was doing the notes today, and it says underline.
So A plus B would say start with A, add B to it, and we'll draw the resultant in red here. This is where you would end up. So if we wrote down what we got, we've gone 1 to the right and 2 up. So the result of adding A plus B would be 1I plus 2j. And I'll draw my resultant in red all the time, yes.
Is this still a Cartesian plane, or?
Right now we're doing two-dimensional ones. We're going to do three-dimensional vectors and add them together as well. Yes.
This sounds hard.
Yes.
It's hard.
This sounds hard?
Yeah.
No, it's not bad.
You just gotta let your mind go blank. It's the right mind. This should be the year that I draw.
So if we have B minus A, so here's B. I'll start it there. And minus A would be A, but in the opposite direction. If we look at the resultant here, we've started here and we ended here, means we've gone 3 to the right and 4 up. 3 to the left, sorry. Riley. Riley.
Yeah. Giving this little boy a house.
There's a very, very, very small spider.
There's a very small spider on his paper.
It's like,
We're watching his journey.
the size of a grain of salt.
And finally, 2 B's plus 2 A's. So if I started with B, I'm going to start here. No, where am I going to have room? Right there. All right, I'll start here. 1 B, 2 B's. Oh, this isn't so good. Here we go. Here we go. No, watch this, watch this. I'll start here. There we go. There we go. 2 B's plus 2 A's would result in, we started here, we ended here, which means we've gone 2 to the right and 4 up. Now, let's look at our vectors that we've added and our resultants as column vectors. And I want to tell me if you notice anything. So A is 2, -1. That's the blue one. And B was -1, 3. And if I do part A, the resultant was 1, 2. Okay. If we look at B, in B, we did B minus A. So B was -1, 3 minus A, which was 2, -1. And our resultant that we got, our answer that we got for B was -3, 4. And in C, we did 2. And then in C, we had 2 of A plus 2 of B. And our answer, our resultant was 2, 4.
Are you self-conscious about your fours now?
I'm very self-conscious about my 4s. I wasn't before, but I am now.
It still looks like a 9.
Be nice.
No, it doesn't, please.
I want to hurt him more.
So, is there a much easier way to add these rather than drawing them out every time? Just like adding matrices. They're the same size. You add the corresponding elements per se. Same thing, even if you had scalar multiplication out in front, you could double each of those things and add them. And that's all vector addition is. So how did I get this set up if we view the whole thing at once? So because it was 2i minus j, that's 2, -1 is a column vector. And b is -1, 3 is a column vector. And then I'm just adding the corresponding elements to add my vectors. But we can see why it works when we look at the graph. So all we are doing is adding the separate components, and this is going to be really nice in 3 dimensions because it's really hard to draw everything in 3 dimensions and then count it out perfectly.
How about 4 dimensions?
So I plus j is k.
No, I, J, and K are 3 separate dimensions. So I times J is
No. So if you had these vectors, p, 3, -1, and 4, plus q, -2, 0, and 3, your resultant vector will be 1, -1, 7. And if you took p and subtracted half of q, you would get 4, -1, and 4 minus 3.5. Whoops. 4 minus 1.5. No. 4 minus 1.5 is 5 halves.
Brackets for matrices or
Yeah, you can use square brackets.
how about those squiggly brackets that have?
No, I don't like squiggly brackets. Okay?
Alan gave me.
No, it's Riley, it's not me. Also me from living in I put it on my test, and then I was like pushing it with my pencil, and I think I crushed it with my lead. And I blew on it to see if it would get up, and it just went right off. So,
Okay.
but don't worry, if I didn't
So
do it,
try
I'd
these
be
next
number
two on your own. You can visualize what's happening by drawing a vector AB somewhere, another vector B to C. When you're drawing vectors and you're adding them together, we always attach them head to tail. So AB plus BC would go to A to C. So we have our starting point here. We go to B first, then we start at B and go to C. That would be the same as going from A to C. And showing what this would be, we would take our first vector, add our second vector, add the corresponding components, and you get 3, 9, -8. Now, we're not drawing our diagram to scale by any means. I mean, these are 3-dimensional vectors, and we've drawn it in 2-dimensional space.
Keep manipulating.
Okay? In our next example, you have AB and you have AC, and you want to get B to C. So if you look, if I want to start at B and go to C, how would I do that using the pathways that I have? Well, first I could go B to A. I should change the color. First I could go from B to A and then go from A to C. And that would be like starting at B and going to C. B to A is just the negative of A to B. So I've taken my vector A to B, -3, 2, -6. I put a negative in front because that would change its direction. Plus A to C ends up being 4, -2, 11.
Makes sense.
Looks good?
I mean, it makes sense because I would.
And I got a cartoon for you to end,
Oh yay! Is it about vectors?
and it is about football,
Oh yeah, yeah.
but no dislocated shoulders in the comic.
Can't read that.